there's actually just one more thing that is completely disconnected, which is this V-gap. And I tell you what, this V-gap thing really is a pain. But, you know, we gotta do it together, right? We will hold out, we will be strong together. Let's actually just temporarily change the setup a little bit. I'm going to get this switch node here. I'm duplicating it and just plugging it in here. And let's switch up these models to something reasonable, like 4 in my case is this corner, which means that I'm getting some more or less coherent block. And I'm now going to work with this node, so I'm not distracted by all the upper floors and rings and corners that I've put in here. So let's take this all the way back up here. And I'm going to switch it off for a second so I can put some different model into false. Yeah, like that. So my idea is now just to work on a clean slate and then just integrating the node setup we do now into the building when we're done. So yet again, we start with an input position. And you'd think, in general, it is quite comparable to our rings, because, again, we want something that has gaps in between this and has a repeating pattern. So it has to do something with positioning and modulo. And that's correct, it's just a little bit more problematic for reasons that we will discover in a moment. This time I'm dragging off the position and just type in separate XYZ and get this one. And now obviously we wouldn't like to take a look at the Z-axis, but at the other two axes. Let's start with the X one, for example, the X-axis. I'm going to search for compare node. There we have it. Plug in the X and put it into the switch. Right, now we're comparing the X position with the greater than value. All of that works fine. Now let's change it to equal so we can address a specific value here. But if I type in 2 or 3, nothing happens. And why is that? Well, let me turn back on the grid and take a look at this situation. And you might notice with your sharp eyes that we have one axis that has a width of 5 units, and we have one that is only 4 units wide. And this reflects in the model by having a gap or a seam between two building parts exactly where the axis meets the building. And here the axis kind of goes into the middle of a building block. And that means, since the origin of every building part is square in its center, that this one actually lies on a nice round number for the y-axis, right? So the y-axis, this would have the number of 0, but which of these two parts would have a value of 0 on the x-axis? Well, none of them, because they actually lie 0.5 units to the left and to the right. So my expectations are, if I would change this from 3 to 2.5, then we would have a change here. And wow, that was that was very close. I almost missed the building. Let's actually drop it down to 1.5 for now, so it's a little bit nice in the middle. So this is a little bit annoying because now we can't feed an integer into it, right? We could use a math node again, search for math, right? And just add a value of 0.5 to whatever we plug in here. And now if I put in, 1, it would be, added together to 1.5. And now I can work with the whole value again. But here comes now the problem. If I would change this value to a 6, now it would disappear again. And I actually do not want to add 0.5. So that's a huge pain. And how do we automate this process? And yet again, this is the part where we will talk about modulo, because in the previously mentioned video, I've already shown you that you can actually detect whether a number is even or odd with a modulo command. So we can read out if one of these values is, uneven, and if it's a 5 or a 7 or whatever, then we can add a value of 0.5 to make it work. And when the user then changes this value back to something even, then we essentially mute this addition and set it back to 0. Sounds complicated, and because of that, we're not going to do it right away. Let's set up the rest of this node group first. So let's change it from add to modulo. So we get back to what we originally wanted, right? And then let's plug it in the center here. I will raise both of them back to an even level so we don't have to work with these half units for now. And let's make them a little bit bigger as well. I need to increase, yes, this one should give me a good overview. Now we have a lot of space to work with, a big canvas to see all of our mistakes. Let's take a modulo of 3 again and compare it to a value of 0. And right away it worked like a charm. And now let's take a look at detecting if this value is even or uneven. So first of all, we're going to need the value. So I'm taking my group input node, bringing it up here, and I will duplicate this modulo node and drag it in here. Right, we have learned that if we modulo something by a value of 2, it will either return 0 or 1, because it can't return a value equal or more than the modulus. Which is great because 0 or 1 is essentially like a boolean, it's like on or off, so we could put it into a switch, or we can choose a different route, which I think is more elegant, which you're going to see in a moment. For now, let's change the x value a little bit lower to 29, so everything disappears. Let's now fix it up by duplicating a math node, bringing it into the x, and just hit it with a good old add, right? We add 0.5, and as expected and as shown previously, it works. What I don't like is that everything has shifted to the right, and now it has left me with an empty row here and a full row there. That doesn't look great. We can address this in a moment. For now, we realize that adding 0.5 at this point is good. Well, now what kind of output do we expect if we modulate a value of 29 on the basis of 2, or however you say it mathematically correct? Well, this value should return 1. So, I mean, 1 is pretty close to 0.5. The only thing I actually have to do is get myself another math node, set it to divide, and just divide 1 by 2. And 1 divided by 2 is 0.5. And if I would have an even number there, the modulo would return 0. And 0 times 2 remains 0, so we can essentially ignore it. So great, I mean, we're done. We can just plug this one into the 0.5 here. And now this setup works with both even and odd numbers. In order to make sure that whenever I have an uneven number, this kind of left shift does not happen, you know, where we have like a gap of 2 here and a gap of 1 there, I will mirror this setup. How can we do that? And this is very simple. We have to understand that this x value will return 1, 2, 3, 4 up until infinity, and -1, -2, -3, and whatever up until negative infinity. Great way to mirror it would be to turn the -1, -2, whatever into just positive 1, 2, 3, 4, whatever. And there's a math node for this as well. So if I duplicate this modulo and put it from modulo to be a absolute, it will convert all negative numbers into just the positive counterpart. So drop it in between the x value and this add node, and suddenly we have mirroring. And now you kind of have to decide which is the lesser evil. Do you rather want symmetry, but an uneven distribution of rings towards the center? Which I prefer, because if my building is less wide, you know, it gives a little bit more character because it's a little bit more random. Or you can just choose to have an asymmetrical building that prefers to keep the gaps clean. But this is the way I will do it, and the rest is up to you, really. Next up, I will take my modulo node here, which right now has the value 3 in it, or whatever you've written into it, and I will go to node here and just check this color box so I can find it more easily. This is the one we need more often because this is the one we change the frequencies in, right? Another thing that I kind of dislike right now is, just for confusion's sake, I have made like the little confusing blunder of kind of putting the wrong numbers in here, because right now it is kind of the opposite of what we expect. These thin lines here, which are just 1 wide, those are the gaps, and everything else is supposed to be a window. So I hope that doesn't confuse you too much, but I'm just going to quickly switch around these two values. I'll put this like that. All right, that is more like what I expected. So we have windows and we can break them up with gaps. However, there's a little problem as soon as I change this value to, well, let's put it back down to 3, for example. And it looks still okay, right? I have these gaps here and these gaps here, but I also have a gap right there in the corner. In principle, this isn't a problem because this corner will be overwritten by our corner model, so we won't see it. But when I pan around the camera, you can see that we have also replaced all the windows on this side with a gap. So as a comparison, put it back to 4, that's all right. If I put it down to 3, suddenly everything is gap. Why is that? Well, if we take a look from the top down, and you can see some slight discoloration here in these slices where our gap is, that we have essentially taken a slice out of the entire building and converted the slice to be a gap. And well, as it happens right here, the entire wall is part of that slice. If I would take a cube for visual aid right now, and you'd imagine that this cube goes infinitely into all directions other than the x-axis, right? I'm just going to leave it that small so it's a little bit easier to see. We are essentially just looking at a cutout, and I do not want that. I'm okay with this slice extending infinitely on the z-axis because I actually do not want it to be smaller. Otherwise our gaps would stop somewhere in the middle. That's not good. But I also don't want this slice to extend infinitely on the y-axis, which is like the other axis. So what I rather would like to have is a slice that looks rather something like this. So when I take a look at like a wall, it will only return this specific part, but it does not mess with this wall at all because it's, well, too thin to affect it. I think visually that's easy to understand. Mathematically it's a little bit more difficult, but I'll try my best to make it to make an explanation. We are taking this separate XYZ node right now, which is taking a look at the position. But as it so happens, we are just looking at the X position. And we do not care about the Y and Z position at the moment, which means no matter what value comes out of here or comes out of here, it takes no part in the overall calculation. So really only the x-axis counts, which is the equivalent of the slice. So in order to turn the slice into a pillar, we would need to kind of bring the y-axis into the calculation. But right now we have nowhere to connect it. So instead of setting this equal node to a float, I will do a little conversion right here. I am disconnecting the modulo node, and instead of float, I will set it to vector, right? And now we can compare something to something else which has 3 values instead of just 1. Great. Now I can't connect this value back up. We will need a combine XYZ node, and now I can plug the X back in. Essentially, we have done nothing because now we have the exact same situation as before. We are comparing a varying X value to some other vector. So right now, these two values here are 0 and these are also 0, so they will always return true. It's essentially the same as before. So let me now go ahead and just take this Y value that we have from this separation and bring it all the way over here and plug it into Y. So now the Y position is part of the calculation as well. But as it so happens, since Y at the moment has a value of 0, we are essentially just looking at a pillar that is positioned here in the center, and you can actually still see that this piece is different. So in order to make it work, I will move this pillar over, and I'll do that just manually for now. So how much would I need to move this pillar? Well, -1, -2, -3, -4, because we're moving it in the negative direction. So let me quickly type in -4. And now our pieces are lined up with the correct Y position. And now we're only taking a look at the pieces that our modulo returns if they are also on a Y position of -4. That means 2 things. First of all, this wall here is now safe because all of these pieces are not on a position of -4. And it also means that the other side that has previously worked is now destroyed because this wall is obviously on the position +4. If I would change it up to +4, Now this would work and this would not. Well, that is stupid, but it's rather easy to fix. We do it the same way as we did it before. You remember this absolute node, which turns every negative value into the positive value. Instead of receiving any negative 4 value from y, we're just going to duplicate this and plug it in here as well. And now, as long as there's a positive value on this axis, both walls should work again. I'm duplicating this combine XYZ node and I'm copying the 4 that I've manually put in into here, so I can actually access the individual values. Now, obviously it's no solution to just type in 4, because as soon as I make the building a little bit deeper, well, it won't work, because as you can see, it doesn't move with the building. It just stays at this 4 position. Let me go back to 8 the way it was originally. The building is a value of 8 deep, because it goes 4 into one direction and 4 into the other direction. So how do we get from 8 to 4? Well, we divide it by 2. I'm plugging in the y value here instead of the x one. I'm saying x and y because I want to avoid saying depth. And this should convert our 8 into a 4. So let me plug it in to the y slot. And now, upon changing this value, it should continue to work. I know that was rather complicated, and I don't know if there's an easier way to explain it. I've tried my best. It is how it is, I guess. There's only one more thing to do, to copy this entire section over so it works on the other axis as well. So I'm taking my group input and my position node and bring them over a little bit to the left, because I don't want to duplicate them. Select everything else, including up until this equal node. Control Shift D, move it down to maintain the connection. Let me quickly rearrange it so it looks a little bit cleaner. And now let's plug in this new duplicated group. We have to swap around X and Y, so I'm quickly gonna do a little switcheroo. We have to swap these 2 values. See how cleverly I've avoided saying it again. So I will bring this down here, this up there. And now Blender has tried to automatically make the life easier, but actually made it harder. And now let's try it out. This works and this works as well. Luckily, this wasn't too difficult. Let me quickly dissolve these reroute nodes I put in there for utility. And the last thing is some very simple Boolean math. Search for Boolean math, plug it in and connect both values and set it to OR. Now we have vertical gaps that work on both axes. You now have to make a decision. Do you want to expose both individual values and want the user to have the ability to have different frequencies on both axes? I personally don't want that. I think it's okay to just have one value. So I'm bringing over my group input a little bit. I'm going to create a new input, which I will call gap frequency. I will minimize it at 0 and maximize it at 100 again or something. Now I can simply connect this gap frequency to both of the modulo inputs like this. Now right now it's set to 0, but as I increase it, you can see now that the gaps appear and they become larger and they become smaller. We have to put this entire thing back into our masks node. So this is like the last order of business, but then we are pretty much done. So first things first, remove the switch node that we did for utility, and I'm rather, oh my god, don't crash on me Blender, and reconnect the original switch node that we had in here to get our old building back. And now you can see where we did it outside here, because this node already has so much stuff in it and I don't want it to be more complicated than it is. I will move this one over here and drag with shift and right click over all of these connections, and I will delete these input nodes. Take the entire selection here, Control C, and make sure that your mouse is in this window, in the node window, or otherwise it won't work. It's always a little bit confusing for me. Go into the masks value, tap in there, and Control V. And now move it somewhere where it's safe, down here perhaps, and connect this OR node to the VGAP value. Let's make a duplicate, yet another one of this group input. Control D it over there. Actually, we could have copied the position over as well, I just realized. So let's quickly set this one back up like that. We do not actually have all the inputs that we need. So let me quickly create them. Width, depth, V-gap frequency, all back connected. I can see them already taking effect. And now let's tap out and actually connect them up with our general inputs here, V-gap frequency. Oh, I've just called it gap frequency, but that's okay as well. All right, gap frequency, and just to be sure, I will do the same here. And here we are. Now let's check it out. Make the building a little bit wider, make it a little bit deeper. Great. As of recording, I have no idea how long this tutorial is. I assume it's quite long, so let's put the details in the last tutorial. If you have any other ideas, I've read a comment of making an entire wall blank. I am definitely going to try that out. That shouldn't be too difficult, and I think the idea is great. If you have another idea that you think is maybe quickly and spontaneously doable, put it in the comments and I'll try to think about it. No promises though. Thank you so much for watching this far. I know this one was a little bit more of a difficult episode, but I mean, we all have difficult episodes, don't we? So I'll see you around next time and have a great week or something, I don't know.